Today our lesson is on factoring linear expressions. Factors are found by dividing an expression into equivalent groups. A factor is different from a multiple. A factor divides a number completely without leaving any remainders. The factors of 8 are 1, 2, 4, and 8 because 1 times 8, we can make one group of 8, 2 groups of 4, 4 groups of 2, or 8 groups of 1. There's only 4 factors. There's an infinite number of multiples for every number. So the multiples are found by multiplying consecutively. The multiples of 8 are 8, 16, 24, 32, 40, 48. This would be etc. 8 times 1, 8 times 2, 8 times 3, and so on. So notice the multiples, there's infinite multiples, but there's a finite number of factors. Factors are found with division. Multiples are found with multiplication. How do we find the greatest common factor of two terms? To find the greatest common factor of a pair of monomials, we can factor them using two methods we're going to look at. This first method I call a factor T. We can draw a T and then look at all of the possible combinations that can make that number. So 36 can be made with 1 times 36, 2 groups of 18, 3 groups of 12, 4 groups of 9, or 6 groups of 6. 30 can be made with 1 group of 30, 2 groups of 15, 3 groups of 10, or 5 groups of 6. Now we look at our factors to determine which one is the greatest common factor. Notice that the one they have in common, and it's the largest one they have in common, is the number 6. So the greatest common factor of 36 and 30 would be 6. Here's another method we can use. This is called a prime factor tree. We can factor the number 27 by finding two numbers that we can multiply together to make 27. 9 times 3. Now notice 3 is a prime number. 9 is still composite, so we can divide 9 into 3 times 3. Now 27 is divided into 3 prime numbers. 3 times 3 times 3. Next we'll look at 15. We can divide 15 into 5 groups of 3. 5 and 3 are both prime, so we're done factoring 15 into its prime factors. We can highlight or circle the prime factors that they have in common. Notice that the prime factors here are 3, 3, and 3 for 27 and 5 and 3 for 15. They each have at least one 3. So the greatest common factor of 27 and 15 is 3. If we look at 42 and 28, 42 can be broken into 21 times 2, and 21 can break down to 3 times 7. So we have 3 prime numbers. 28 divides into 14 times 2, or 2 times 7. Notice with these two numbers, they have two numbers in common. They both have a 2 and a 7. So to find the greatest common factor, we multiply 2 times 7. The greatest common factor of 42 and 28 is 14, because 2 times 7 is 14. To find the GCF, or the greatest common factor, of a pair of monomials with coefficients and variables, we first have to find the greatest common factor of the coefficients, 12 and 28. So we look at the numbers. The greatest common factors of 12 and 28 are 2 times 2, or 4. This is a prime factor tree for 12 and 28, and the two prime numbers they have in common are 2 times 2, or 4. So the greatest common factor of these coefficients is 4. Next we look at the variables. We have to find the variable that they have in common. Notice that 12x and 28xy both share an x. So if we're going to find the greatest common factor of these two monomials, the greatest common factor of the coefficients is 4. And the greatest common factor, or the greatest common variable, is x. So the greatest common factor of these two monomials is 4x. Let's find the greatest common factor of these monomials, 16abc and 8a. First we find the GCF of the coefficients, 16 and 8. Notice 8 is a factor of 16, so the greatest common factor of these is 8. The common variables of 16abc and 8a are a. They both have an a. So the GCF of 16ABC and 8A is 8 times A. So find the greatest common factor of the coefficients and the variables that they have in common and make this your answer. Algebraic expressions like this one, 2x plus 8, can also be factored. Let's look at a model for 2x plus 8. They can be shown with equal groups. We have 2 x's and 8 1's. If we separate these tiles into 2 equal groups, we'll see one x with 4 1's and another x term with 4 1's. So we have 2 groups of x plus 4. So if we pull out the greatest common factor of 2 and 8, you see it's 2, and we will have 2 groups of x plus 4. We can separate these into 2 groups. 2 is the greatest common factor. That shows us 2 groups of x plus 4. We can use the distributive property to check our answer. 2 times parentheses x plus 4 is equivalent to 2x plus 2 times 4, which is 8. So 2x plus 8 equals 2 times x plus 4. Here's another example of an algebraic expression that can be factored. We have 3x minus 15. We can separate these tiles into 3 groups. The greatest common factor of 3 and 15 is 3. So we put the 3 on the outside, and notice that if we break this into 3 equal groups, each group has x minus 5 tiles. So 3x minus 15 is equal to 3 times x minus 5. We can use the distributive property to check this. 3 times x is 3x, and 3 times negative 5 is negative 15. Let's factor 12x plus 18. Find the GCF of the terms and the expression. The greatest common factor of 12 and 18 is 6, so we're going to pull out the greatest common factor and place this one on the outside. So from 12x plus 18, we pull out a 6, the greatest common factor of 12 and 18. Next, we find which numbers will go in the parentheses. 6 times 2x is 12x, so 2x is the first term in the parenthesis, and 6 times positive 3 is 18, so plus 3 is the second term in the parentheses. We check our answer with distributive property. 6 times 2x is 12x, and 6 times 3 is 18. Therefore, these two are equivalent expressions. This is how we factor an expression. Here's another example. Let's factor 30x minus 40. We start by finding the greatest common factor of 30 and 40. The greatest common factor is 10, so we pull out the GCF as the outside term. In parentheses, we're going to find the terms that make the equivalent expressions. So 10 times 3x is 30x. 30x divided by 10 is 3x, and that is why 3x goes on the inside. So 10 times negative 4 is negative 40. Negative 40 divided by 10 is negative 4. So our equivalent expression is 10 times parentheses 3x minus 4. Let's check our answer using distributive property. 10 times 3x equals 30x. And 10 times negative 4 is negative 40. Therefore, these two are equivalent expressions. If we factor 17 plus 20xy, we start by finding the greatest common factor of the terms in the expression. Notice that if we factor these two numbers, 17 is already factored because it's prime by itself. 20 is factored into 2 times 2 times 5. They have no factors in common, so because they do not have any common factors, we say they cannot be factored. This expression cannot be factored. In summary, factoring divides an expression completely without leaving any remainders. We can use models to show factoring. Factoring algebraic expressions is like reverse distributive property. We can check our factorization using the distributive property, and we can find the greatest common factor of two numbers using prime factorization. Coefficients are numbers, and variables may both have common factors. And that's all.